Welcome to the Neely Center's video series on decisions and ethics. I'm Ali Abbas, and today we have a very special guest, Vint Cerf, Vice President of Google and someone who many people would refer to as one of the fathers of the Internet. Welcome, Vint.
Thanks, Ali. Glad to be here.
Right. So let's start by, I would like to ask you a little bit, tell us a bit about your background and how you got into the field and the early history and creation of the Internet.
So how many hours do we have for this?
A few.
I'm kidding.
We will.
Right. So although I was not born in California, I grew up here. Moved here in 1946, was in the San Fernando Valley for a good portion of my growing up period. Went to Van Nuys High. And ironically, several other key people in the Internet story also went to Van Nuys High. I mean, it's just sheer coincidence, but it's interesting. I went to Stanford University for my undergraduate work and came back to Los Angeles. Yes, it is a great school. Went back to Los Angeles to work for IBM, and then after a couple of years realized I needed to go back to school again to get a deeper understanding of computer science, operating systems, programming languages, and things like that. So I went to UCLA, finished a PhD there, but while I was there, I got very involved in a project called the ARPANET, which was initiated by the Defense Advanced Research Projects Agency. And so that organization was trying to figure out how do we connect a dozen universities together that they had been spending money on to do research in artificial intelligence and computer science. And every one of them, of course, wanted a brand new computer every year, to do world-class computing. And even the Defense Department couldn't pay for another $6 million machine every year for 12 universities. So they said, we're going to build a network and you're going to share. Of course, everybody hated that. But we did build the network. It was called ARPANET. A company called Bolt, Beranek and Newman from Cambridge, Massachusetts, won the contract to build this packet switch net. And packet switching at the time was considered to be outrageously impossible. AT&T thought it was crazy. Although in the end, they were happy to sell dedicated circuits to let us build the ARPANET. So Len Kleinrock, in whose group I worked, had done the technical analysis of the mathematical behavior of store and forward packet switch networks to show that it would work. But the proof, of course, was in the implementation. So I worked on that project doing what were called the host-to-host protocols. Steve Crocker, my best friend in high school and still my best friend today, led the network working group that developed not only the host-to-host protocols, but other application protocols as well, like file transfer and so on. So we got all that working in the late 1960s and early 1970s. And then I finished my PhD and went up to Stanford to join the faculty. And I was then doing research on computer networking. And about that time, Bob Kahn, who had worked on the ARPANET project at Bolt, Beranek and Newman, had gone to DARPA. And I had gone up to Stanford. And so in the spring of 73, Bob Kahn shows up in my lab saying, we have a problem. And I'm saying, what do you mean we? And it turned out he had, based on the success of the ARPANET, had concluded that the Defense Department could make use of computers in command and control in order to use those machines to manage our resources better. In theory, a smaller force could overcome a bigger one, a force multiplier. So he concluded that if we were going to take advantage of this idea, that we would have to put computers in mobile vehicles, ships at sea, and aircraft. And the ARPANET had been designed with dedicated telephone lines. And you're not going to connect the tanks together with wires because they run over the wires and they break. And the ships get all tangled up and the planes never make it off the tarmac. So he had started developing a mobile packet radio system and a packet satellite system to satisfy all those communication requirements. Then comes the problem. Well, how do we connect all these packet switch nets to each other? They were all different packet sizes, different error rates, different delays and latencies. How do we make it look uniform? That was the Internet problem. And over the course of about March to September of 1973, we solved the problem, did a design, which was published in May of 1974, describing how this could work. And so by the beginning of 1974, my team at Stanford developed the detailed specifications for what was called the Transmission Control Protocol, TCP. And then we started implementing it in 1975 and found mistakes and bugs. And so we iterated for a while, and until about 1978, we had a stable design. By that time, I had been invited to come to Washington, D.C. and run the Internet program for the Defense Department. So I became a program manager. Bob Kahn eventually became the director of the Information Processing Techniques Office. And I stayed there to run the program until 1982. So that's sort of a chronological summary of some of the history that leads us up to the point where the Internet gets turned on in January of 1983.
Did you imagine at the time that it would have the ramifications and implications that we're seeing today?
You know, the simple answer, of course, would be no, but it's not true. That's not a fair answer. If you think about this a little bit, first of all, remember that the ARPANET project, the predecessor, had already encountered electronic mail. A guy named Ray Tomlinson at BB&N, Bolt, Beranek, and Newman, realized that he could do networked electronic mail if he just forwarded the messages through the network and got them to go to the right target machine. And then he had to figure out, okay, I get to the right machine, how do I tell it which user it is that I am supposed to be sending this message for? And he needed to separate the machine identity from the user identity, and the only character he could find on the keyboard that wasn't already in use by the operating systems was the @ sign. And so it's kind of natural, user @ host. So that's the origin of the @ sign in our email. So he does this and demonstrates it in sort of mid-1971. Everybody gets excited about this. We all realize what a powerful tool this is. It's computer-mediated communication. We no longer have to both be awake at the same time to communicate, so we can overcome time zones and everything else. And so email was already in place before Internet work was even started. We also had access to something called the online system, which was developed at SRI International by Douglas Engelbart. Engelbart was one of these visionary guys who's thinking 30 years ahead. He believes deeply that computers should be used and could be used to augment human intellect, that collaboration among people mediated by a computer would enhance our ability to understand things, reach conclusions, solve problems. J.C.R. Licklider was the director of the Information Processing Techniques Office, who also believed this. So Vannevar Bush and the other two believe implicitly that computers are going to be part of our future. So we were using Doug Engelbart's online system as a document production environment. The reason this is important is that he had to invent a mouse in order to point on the screen at a document, a location in a document, to say edit here, or he invented hyperlinks so that you could click on a hyperlink and go to a related document. And so he built a World Wide Web in a box. I mean, not to be too careful about the definition of what the World Wide Web is.
Now, the mouse existed at Xerox.
No, it existed. Well, no, it was SRI International that invented the mouse. The Xerox team came from SRI International, brought that idea with them, built the Alto machine as a personal computer, built the Ethernet for high-speed communication, 3 megabits a second at that time. So Xerox PARC, 1972. I am at Stanford late in 72. They're a mile and a half from my laboratory. I have graduate students who are going back and forth at PARC. I have people from PARC who are coming to some of my seminars. And so there's some cross-fertilization going on. They were working on something called the PARC Universal Packet. But they couldn't tell us very much because Xerox decided they wanted to keep it proprietary. So we got some kibitzing from them, but not necessarily a full layout of what they were experiencing. And in the meantime, of course, I'm trying to plow through with my graduate student team the design of TCP, which eventually turns into TCP/IP as we split the Internet protocol off in order to do real-time communication. So that's a long way of saying that we actually had some appreciation for what this technology could do. And we used it to do a lot of the applications that we still use today, electronic mail, file transfer, remote access to time-shared machines. But of course, the most significant change after the internet finally gets operational in early 83 and then becomes commercially available in 1989 is Tim Berners-Lee's development of the World Wide Web. And to be honest, Tim releases this out of CERN in Geneva in sort of December of 1991. Nobody notices, except for a couple of guys at the National Center for Supercomputer Applications, Mark Andreessen and Eric Bina, who say, oh, this is cool. Why don't we build a graphical user interface? So they develop the Mosaic browser. They release this. It makes the internet look like a magazine with formatted text and images and eventually, audio, video, things like that. Everybody notices, including Jim Clark, who had been the founder of Silicon Graphics, which was a heavily used machine for computer-generated graphics in the movie industry. So Clark drags these guys out to the West Coast and starts Netscape Communications around 1994 or so. They go public in 1995. The stock goes through the roof. The dot boom is on. Every venture capital guy is throwing money at anything that looks like it might have something to do with the internet. This continues for 5 years or so, and then in April of 2000, everything falls apart and the dot bust happens, except in that period of time, from 1989 as commercial service gets started to that period in 2000, the internet is growing at 100% a year, and it continues to grow. Not today, at that rate for a while, not today, but still growing. And so this introduction of this new way of sharing information on the net had a profound impact on its accessibility and utility. What we had achieved is this infrastructure that was infinitely, well, not really, but largely expandable. It dropped the barriers to access to computer communication to as close to zero as possible. We had given away the design of the internet for free with no patents or any other constraints deliberately in order to stimulate adoption and use. So as the general public encounters the World Wide Web, they have the ability to inject content into the network with very little barrier, and of course to get access to that information. In fact, there was such an avalanche of content that flowed in that we now couldn't find anything, and we needed search engines. So we got things like Alta Vista and Yahoo and eventually Google, Bing, and so on. So this question of did we know what was going to happen? No, but there were milestones in the course of the evolution that signaled that this was going to be a big deal. And it was the commercialization in 1989 of the service as opposed to commercialization of the equipment like packet switches from Cisco Systems or Proteon or others. It was the commercialization of the service and the arrival of the World Wide Web that really conflated these two things. Then there's one other thing which I think was equally significant, and that's the arrival of the smartphone in 2007. This is Steve Jobs and Apple. And this is very interesting because the mobile phone design work was started in 1973 by Marty Cooper, who was at Motorola at the time, which is ironically the year that Bob and I started designing internet, and we didn't know about each other. And then in 83, we turned the internet on. He turns on the first mobile phone service. We still don't know anything about each other, except that a friend of mine, Danny Cohen, invited me to lunch in 83. He said, I have to show you something. I said, well, okay, I'll come to lunch. And I come there and I see this thing sitting on the table. It's about this tall with a whip antenna. And I said, what's that? And he said, it's a phone. I said, where are the wires? And he says, there aren't any. I said, well, how does it work? And I asked him a bunch of questions, and finally he said, I don't know the answer to that. Why don't you talk to the guy that developed it? So I called Marty Cooper on the phone. And the first question I asked him, how this thing, I said, Marty, how long does the battery last? And he says, well, about 20 minutes, but you can't hold the phone up longer than that anyway. It weighs 3.5 pounds. So, and at that point, 1983, the mobile phone and the internet are on parallel courses. They don't really come together at all until the smartphone shows up. And at that point, you see a phenomenon which is very important to understand. two technologies that are mutually reinforcing. The mobile phone makes the internet more accessible. The internet makes the mobile phone more useful because of all the content and functionality that's on the net. And so those two things together have really colored the last decade of the evolution of the internet and on the products and services that go with it.
And then the more apps that started appearing for
exactly right. Yes, because we have a platform. So the interesting thing about all of this is the layering that's going on. The internet is a layered architecture. TCP, IP is the sort of the core layer. TCP and the other real-time protocols are just above that, and then there are utility protocols like file transfer. When we get to the World Wide Web, it's another layer. The hypertext transport protocol sits on top of TCP. And then, on top of the mobile phones, we get APIs that make it easy for people to build applications, even if they have no idea how the mobile telephony part works.
Yeah.
And it's this isolation of knowledge, of necessary knowledge, and the stability of the interfaces, whether it's a stable protocol interface or a stable API, that the longevity and stability of those interfaces allow people to do things without having to know very much at all, or if anything, about how this works underneath.
Yeah.
So you create this opportunity for invention without a whole lot of overhead.
Yeah, that happens. Now we're hearing more and more because information is becoming more prevalent because of the internet, and there's a lot of issues about privacy. And that was probably something coming. What are your thoughts now about data and privacy and some of the issues that we're hearing today?
So I think that we are far more conscious now of the fact that privacy is difficult to come by. And I have to tell you, though, that when I was 19, I lived in a little village in Germany. It's called Beutelsbach and had about 3,000 people in it. And I lived in a little, up on top of a hill called Landgutburg. So it turns out that this is 1962, and the postmaster knew what everybody was doing because nobody had phones at home. You had to go to the post office to place a phone call. He would place the phone call for you, and then you'd go in a booth and talk. And of course, he's sorting all the mail. Everybody knew what everybody was doing. A little village is not a place where privacy is easily obtained. Now, I'm not arguing that therefore privacy is weird or odd or a new idea or something. But there is something interesting that happened sociologically. As big cities formed and people migrated to those cities from farm territories, what they got was not quite privacy, but they got anonymity. You didn't know everybody in the city, unlike a small village. And so you may have had the sense of privacy because you were sort of anonymous, but it's not the same thing. Well, now everybody has a phone. All the phones have cameras. We have applications that let people upload virtually anything onto the net. And so you don't know, that somebody has taken a picture, and sometimes it's inadvertent. So here's a scenario. You're in Egypt, and you're standing in front of the pyramids, and you ask somebody to take a photograph of you standing in front of the pyramids. Somebody else is captured in that image. You don't know who it is. You don't care. Doesn't matter. You put your image up on the net. Somebody else is running around looking for pictures of pyramids, and they find this, and they say, "Oh, I know that guy. Wait a minute. He told me he was in London on that day." So now this guy is in trouble because somebody else took a picture for you.
Yeah.
So, it's this inadvertent sharing of information with its side effects that we are all experiencing right now. So now there are other issues here that we need to take into account. Companies accumulate a lot of information about their users. If it's the phone system, for example, kept track of all your phone calls because that's how we do billing. And everybody understood that. But that information was treated as special. It's only available if it was demanded, for example, by the police department for legal reasons. So companies like Google and Yahoo and Facebook and others, Amazon, accumulate a lot of information about the user's behavior. Some of it's in the normal course of doing business. We're very conscious of the fact that and we're open about the way that we do our business at Google is to use information like what are you searching for to figure out what ad we should show you. And we're very open about that. We don't sell that information to anybody. It's not in our business interest to do that. We only are sitting here saying, if you just did a search, I go reach in my ad bag and try to figure out if there's anything there that matches the search. So we feel that information is sacrosanct, and we hang on to that. We don't share it with anybody. There are other companies that don't necessarily follow all the same rules. Mm-hmm. So the fact that our behavior patterns are the exhaust of our behavior on the net is captured in one way or another by many different parties, and in some cases shared without our knowledge, is a dawning recognition at this point that the online environment, as useful as it has been and will be, is also a place where privacy is hard to come by. And it's not surprising that we're starting to see reactions to that and pressures coming from governments at several different levels and individuals to say, I want to have more to say about what happens to the information about me that I leave behind as a result of my online interactions. So I don't think we have a clear, simple set of desirable guidelines. It's discussions about ethics, for example. It's discussions about privacy and privacy rights that will eventually lead us to some conclusions. The hard part is that this is global in scope. I mean, the internet doesn't know when it's crossed international boundaries. Mm-hmm. And so the preferences and behavior patterns and cultural patterns of people around the world will differ and vary. And figuring out how to do this in a way which is at least compatible at the edges of country borders is a hard problem. So we have to figure out as a society what is it that we will accept and what is it that we will reject in terms of behaviors of individuals as well as companies and governments.
Yeah. Given the advances that are happening in technology and artificial intelligence, how should people in public policy, I mean, they obviously need first to learn about what it is before they can make meaningful legislation.
Don't you wish that legislators actually had that view? Some of them sort of are happy to make laws regardless of whether they know what they're doing. But
yeah. So how would Americans today or people around the world know whether they should accept, click yes, 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 that their information goes? I mean, should they not? Is that something they should think more about?
We're asking users to do a lot. We're asking them to understand a lot about the implications of their choices. And I think that most of the online services need to be much more transparent about the implications of saying yes. Mm-hmm. And certainly we should not ask people to go through reams and reams of terms and conditions and everything else for them to figure out what the implications are. So I think there's real work to be done there to be more clear. There may very well be, I'm not sure how I would put this exactly, but you go to other people for advice about what you should do. You can imagine people being advice givers for safe networking. How should I configure this thing? If I'm running this application, what are the implications of what happens? And if you can't quite get that out of the app that you just loaded, you may actually want somebody to consult that will help you figure that out. This will emerge again in the Internet of Things. I don't know if we're going to talk about that, but that's another big configuration nightmare and another potential hazard about privacy. Yeah. If you have webcams all over everywhere, who has access to them and when and under what circumstances?
We'll get more. Yeah. Net neutrality. What are your thoughts on that?
Well, of course, this has been quite a hoo-ha for almost a decade. And the sort of the not so short story is that in the mid-1990s, there were 8,000 internet service providers in the United States alone. The reason that there were so many is that the business was dial-up over the telephone network with a modem that you connected to a modem bank. Yes, you got it like a cat whose tail is being twisted. When broadband technology came along, it was offered by a small number of providers. The telephone company with DSL, for example, or maybe optical fiber, and the cable company with cable modems. So the problem we run into is that those 8,000 internet service providers became 0, 1, or 2 from the standpoint of any particular consumer. If you were in the rural part of the country, you had 0 broadband service. if you were in the suburban part, maybe you had a choice of one, a cable company or a telephone company. And if you were in the urban part of the country, you might have a choice of two, a cable company and a telephone company. So suddenly your choices drop to a very small number. That's not a highly competitive environment. So we didn't have the discipline of competition to try to limit the behaviors of the broadband providers. So that's one important point. The second thing is that as broadband becomes available, now some applications that would not have worked on dial-up become feasible. Mm-hmm. So for example, if you were a cable company and you were providing video services to your consumers, subscribers, and also broadband internet service, you might encounter a situation where your user is using the broadband internet service to watch videos from somebody else. Now, I'm sure none of the companies would ever do this, but you can imagine the reaction to this. Wait a minute, they're using my service to look at somebody else's videos, so I'm not getting the benefit of selling you access to my... Why don't we just mess up the internet service enough so that this other guy's competitive video doesn't work and drive my subscriber back to my offering? So this verticalization of the broadband internet world led to a potential for that behavior. And the users didn't have much of a response because they didn't have a lot of choice to switch from one carrier to another. And to make matters worse, switching meant a truck roll. Somebody had to come out and tear out some equipment, put in some new equipment. So this led the FCC to conclude that it should establish some kind of net neutrality rules that say you won't mess up people's access to the internet and block them from getting access to where they wanted to go, or interfere with or do preferential charging or something else. At the same rough time frame, the cable companies and the telcos each were regulated differently under the FCC rules. One under Title VI for cable and one under Title II for telecom. And so both of those classes of company would come to the FCC and complain, we're regulated differently, but we're both offering internet service. So can't you fix that? And the fix that was decided was to make the internet service unregulated. So they were being treated the same, which is to say they weren't being regulated at all. But now you try to combine the net neutrality rules with an unregulated service. So the first time the FCC tries to apply the net neutrality rules against a company that appeared to have violated them, this goes all the way up to the Supreme Court. And the Supreme Court says, excuse me, FCC, since you decided the internet is not regulated, you have no basis to force this company to behave any differently. You have no standing. So the FCC, in the next iteration or incarnation, says, okay, let's move this back to Title II, where it's a telecom service, and we can regulate it. But recognizing that internet is not telephony, we will forbear from applying lots of the terms and conditions in the Title II of the Telecom Act. And so we have this partial regulation in aid only of the net neutrality rules. The next FCC that comes along, the current one, decides that this is inappropriate and that there shouldn't be any regulation at all. And so they reverse that decision. So now the consumers have little to protect them. The other side argues, well, yes, you do, because the Federal Trade Commission is still there. And if you're being harmed, you can complain to the FTC and there will be some action taken. But that's a case-by-case kind of process, as opposed to having a fairly crisp list of do not do these things because they are out of scope. So the next possibility, now that we don't have any regulation at the FCC, is to develop a title in the Telecom Act for Internet specifically, which incorporates the net neutrality rules in it. And at that point, you could then invoke FCC for access abuse. That's really what the issue was, is getting access to the internet without interference. For content abuse, you might still turn to the FTC to say that I've been harmed, fraud has been committed, a variety of harms have occurred, copyright violations, all kinds of things. Could be FTC responsibility, and access abuse would be the FCC responsibility. Now, the question is, will the Congress be able to formulate such a title and pass the law, and will the president sign it? But at this stage of the game, we're in a relatively unprotected state because of the recent decision to abandon enforcement of the net neutrality rules.
Yeah. Let me ask you a few questions, Vinton, and this is very enlightening, some of the discussions here. Artificial intelligence, and this has risen back a lot lately in the news, and there are concerns about artificial intelligence and even the ethics of artificial intelligence. What are your thoughts on that?
So I want to distinguish between artificial intelligence and machine learning for a moment. It may sound like a kind of splitting of hair, but it's actually an important distinction. Most of the time when you hear people talking about artificial intelligence, they are thinking about general artificial intelligence. This is machines that are capable of doing the kind of reasoning that human beings do. And I remind you that humans have this remarkable ability to perceive the real world, to build models of that real world, to reason about and to plan with. Most computers don't have that capability right now. So a lot of the excitement that you see is what we would call at Google machine learning. Now, what is that all about, and why has it suddenly become so important? Well, for many years, neural networks were a very confined thing. They were maybe one layer deep. And there were some 1960 books by Minsky and Papert that basically said perceptrons don't work because they can't even figure out whether a graph is connected because they aren't seeing enough of it. But we discovered, the community discovered 5 years ago or so, that we could build a multi-layer neural network, which might be hundreds of layers deep. And we could train that network by exposing it to examples and having it figure out whether, for example, in image processing, is this a cat or a dog? And after a while, the various weights that were associated with the connections would help distinguish one from the other. And for the technically inclined, this is basically mapping the image space into a very high dimensional space so that two things that were different could be separated by a hyperplane.
Yeah. And having more data to train the network probably helps now.
It helps you figure out where is that plane in hyperspace. So we've seen some remarkable successes in image separation or image understanding or image identification. We've had super successes at DeepMind, which is one of the Alphabet Google companies, playing Go. We trained a multi-layer neural net over quite a long period of time to play Go at grandmaster level, and then tested that against grandmasters in South Korea and China, and won all but one game in those series. But the most dramatic thing that happened is that after, it was called AlphaGo, after AlphaGo was demonstrated, the DeepMind guys developed something called AlphaZero. AlphaZero is essentially a system that based only on the rules of the game and playing incarnations of this program with them, with themselves, learned how to play Go in just a few days' time, enough to beat the grandmaster again. But that's just a few days worth of playing the game, starting from just knowing the rules. In several hours, given the rules of chess, these programs were able to figure out how to play chess well enough to beat other chess playing programs, maybe not human grandmasters, but just a few hours. So this is all very shocking, and everybody gets quite excited about that because, well, if they can do that, can they do everything else? And it's an overstatement, an overreach. These are extremely narrow capabilities. Now, having said that, the autonomous cars, self-driving cars, are a very dramatic evolution. What's going on there is a blend of a number of techniques. It's not just machine learning. But the machine learning is very helpful in identifying objects in the field of view, classifying them. But then additionally, we have to say, if this is an X, like a person on a bicycle, this is a pedestrian, this is what we think is a dog, this is a truck, this is a car. Once we've identified them, then the question is, what are they likely to do in the near term? And so now this is reasoning about a world model which has been developed not only from LiDAR images, but from knowledge of detailed maps and so on. At this point, we are reasoning about the world around us in real time. So that's a very powerful evolution all by itself. Am I scared that the robots are going to take over? No. I think of this as tools that we apply to make it easier for us to get our work done. It's not too different than the invention of fractional horsepower electric motors, which let us place muscle power in exactly the amount we needed, wherever we needed it, in whatever size we needed it. So this is placing computing power of whatever size we need, wherever we need it, applying it when we need it to augment our own capability.
Coming back to the idea of driverless cars and the recognition now, character recognition of the objects, who makes the trade-offs?
Most likely thing is the car has been trained, don't run into anything,
right?
First of all. Second, when the car doesn't know what to do, I mean, if it reaches a point where it does not know how to make a decision, it needs to know that it can't make that decision or it doesn't know what to do, and it needs to go into what NASA would typically call safe mode. Safe mode means, get to the side of the road and stop. Get out of the way. So, I mean, this is all oversimplification of what's going on, but I am convinced that it is possible to make these cars very, very safe to use, and especially if you're willing to accept the metric, it is better than human driven.
And we were, the comeback question is, shouldn't it know more information about you? In other words, shouldn't your car know how many people are in there, if we think of utilitarian, rather than just have less knowledge about who's in the car?
The defining problem is about physics. It's about the car being able to react faster than a human being can, to make use of what its controls to avoid collisions. Now, there are still going to be situations where a collision is unavoidable, especially if there are still human drivers on the streets, or some physical circumstance. A tree falls down, and somehow knocks the car out of the way, or something breaks and the car comes flying over the overhead. And at that point, there will be some unavoidable events. Then the question will be whether there was any action that could have been taken to avoid the problem.
In fact, some would argue that given the number of deaths on the highways, maybe 36,000 or something a year, would a good test be how, when auto driverless cars are in place, how many deaths are we going to have now? In other words, we shouldn't anchor on there was one incident in Arizona. Rather, it is overall how many deaths are we going to have with the introduction of driverless cars?
Well, that's certainly one very pragmatic metric. Is to say, did we reduce the number of accidents? Did we reduce the number of fatalities or the number of injuries on the road? That ought to count. On the other hand, we're a funny, litigious society, and when anything bad happens, we look around for somebody to sue, even if they didn't have anything to do with it. And so I imagine we are in for quite a complicated period of time. As liability gets decided, and if we allow the courts to make these decisions exclusively, we will end up with a kind of a barnacle-encrusted ship of law, because each one of those decisions will stick another barnacle on the side of the ship. At some point, we are going to need legislation which defines the nature of liability and how it should be adjudicated.
Another question, what about advancements in medicine and genetic codes and our increasing ability to be able to modify or even, what are your thoughts on that?
So this is an extraordinary day when we have the ability to apply what's called CRISPR-Cas9 to edit genetic sequences to replace a sequence which has an error in it, so to speak, with one which is, should perform properly. It could have very dramatic results. And we have to be careful not to misunderstand that many illnesses are a consequence of a collection of different genetic interactions, not just one particular SNP, a single nucleotide, something or other. So we shouldn't get too carried away. On the other hand, our ability to interact with the genetic sequences is, with some precision, is an extraordinary development. There's something deeper going on, though. For many years, we thought once we knew what the human genome was, that we could then predict what kinds of illnesses might occur. We might be able to correct mistakes and so on, and therefore we're done, right? Well, what we discovered very quickly is that it's more complicated. This is theorem number 206. Everything is more complicated. So genetic interpretation produces proteins. And so the question is, what proteome is being produced? Under what conditions are they produced? How is the gene turned off or turned on? Methylation is a factor. The so-called epigenetics, which are the exterior impacts on the way in which genes get interpreted. But it gets even more complicated than that. We now have discovered that human beings are not just the sum of their genetic sequence. They're also the sum of the microbiome in the gut, which evolved with us, is part of our immune system, to say nothing of digestion and everything else. And so that suddenly multiplies the genetic complement by large factors. And then there's one other thing. Even after we somehow understand all that, there's something called metabolism. It's what keeps us alive. And it turns out that there is a metabolic exhaust. Right? You eat, and then things happen, and your body produces wastes and so on. Actually, understanding the metabolome may be even more important than anything else, because it gives you a real clue about how well is your body functioning. So right now, I see this huge potential for continuous monitoring, continued analysis of our metabolic output, and with the purpose in mind, not of curing disease, but of keeping people healthy. And those, I think, are not the same thing. In avoiding disease by keeping people healthy is a lot better than trying to respond to a disease as a result, for example, of bad eating habits and no exercise and smoking and whatever else causes us trouble.
What about the future? 50 years from now, what will people be talking about, or what will we be talking about? And with the internet and just the types of advances that we'll see.
Well, I wish that I could really make that prediction. I mean, I go back 50 years to 1969 at the beginning of the ARPANET project, trying to imagine how we could have, really put in mind what we do today with all this stuff, with the shrinking costs and size and energy requirements of a lot of the computing devices, which 50 years ago were in big air-conditioned rooms. Now we carry them in our pockets, or we have them embedded in our bodies. That's a big leap. But I can make a few guesses. One of them is that communications will be ambient, in the sense that you won't even think about it. Of course things interact with each other. Of course there's communication in every dimension. Like plugging into the wall to get electricity today, which you generally don't think about until it isn't available. This is what infrastructure is about. You assume that it's there, and you only react badly when it isn't. So I think communications and something which may still be called internet, but it may not work the same way it does today, will still be there. Lots and lots of software surrounding us in programmable devices. We will be extremely dependent on all of that software working properly. I mean, today, if you want to get a sense for the level of dependence, think about what happens when the power goes out. It doesn't take very long before the fabric of society begins to shred, and people are breaking into stores to get food because the store isn't open, not because they're criminals and thieves, but because they can't buy anything, or there's no power, so the mobile doesn't work and they can't transfer funds. So all of these dependencies should worry us some. And as we look 50 years into the future, we should be asking ourselves, what dependencies are we creating that we will then find are harrowing in their loss? And can we build more resilience into the system to avoid the consequences of losing that infrastructure? Other than that, maybe we will truly be vacationing on Mars, and maybe we'll have a spacecraft on its way to Alpha Centauri? I sure hope so. I mean, we've been dawdling all this time. We need to get out to the other stars. And who knows, maybe we even will be approaching the 24th century Star Trek society where they didn't need money anymore because the robots do all the work. Yeah. I've always wondered, I wonder what that transition period is going to be like. I have no idea exactly how you would do that.
Yeah. One more question, and also, maybe 2 weeks ago, we lost Stephen Hawking, and your reflections on that.
So Hawking, of course, was the most striking phenomenon. A man who would have been dead at a much earlier age somehow survived with ALS. I mean, I have several friends who have passed away because of that disease. It's a pernicious thing. It just wastes your body. Somehow or other, interventions and maybe his own determination, his own state of mind, kept him alive into his 70s. And I suspect that has a lot to do with it. I mean, the attitude that you have, the way in which your brain is occupied, may in fact also affect your health and your ability to survive. He was certainly the most brilliant of the physicists of our age. The only possible comparable party with this would be Albert Einstein. And what was lovely about Hawking is that he had a great sense of humor. He managed to reach people at many different levels, composed some books, which I had to read several times before I could quite get the point, like The Brief History of Time. And I always appreciated the fact that Hawking would admit when he was wrong. And so he had a number of different bets that he had placed in which he took one position, somebody took another. The thing that I particularly liked is that he was still alive when we finally detected the first gravity waves. And I wish I could have been there to just talk about it with him. But that was a great moment that proved Einstein's theory that these things should exist, but they were really hard to detect, especially from far away. I'm enthusiastic about this because the National Science Foundation funded the Laser Interferometer Gravity Observer project for something like 30 years, patiently going through multiple iterations. And to see that level of, let's say, trust and determination and patience over a long period of time pay off in this dramatic way is really cool.
Yeah. Final question, Vint. Life on other planets.
Well, I'm convinced that life is likely elsewhere for several different reasons. One of them is that we're starting to see how readily self-replication can happen. We can see bits and pieces of it. Sometimes it's, if you look at clay, calcified clay, you see these chains of chemicals lining up. I mean, it's like, what was the game that used to play where things would come streaming down? Tetris. Think about these things being chemicals aligning, just falling, and aligning and linking up. And so this self-replication possibility seems pretty easy in some sense, in our world anyway. And if you look at the number of planets that have been discovered now, some of which are thought to be inhabitable zones, a lot of them around dwarf planets, little white dwarfs, unlike our own M-type star. There just seem like an awful lot of places where this could potentially happen. I would be frankly surprised if there was not life elsewhere. Whether it's intelligent life, it's a little hard to tell. But I've always been amused by this project, the search for extraterrestrial intelligence. Yeah. Some people said, why would you do that? And my answer is, well, we didn't find any intelligence here, so we were looking for some out there.
Vint, it's been a real pleasure. Thank you very much.
Thank you very much.
Thank you.